This little section is about making and using solutions for different purposes, which hopefully will become blatantly obvious. Nice exercise you might want to get your students to do once they've had a little bit of coaching and training. So to make up our range of dilutions, we've got a stock starting solution and a dilution factor, lovingly known as water. You probably say it's distilled water, but this is just tap water. And that just happens to be some beetroot juice that's knocking around. And I quite like using that, one, because it's cheap and cheerful, but also because we can get some colour into our presentations. So, a stock solution and something to dilute it down. And if we think about osmosis terms, you might have made up a classic 1 molar, 0.8, 0.6, 0.4, 0.2 with the appropriate volumes of beet sucrose or salt. It might not be a bad idea to know just how much a tube holds, and crudely on the side there I've marked a number that says 40. So this boiling tube adds 40 mil to there, 40 centimetre cube. So therefore you can scale up or down the amounts of the volumes that you need. So that just shows, doesn't it, the two extremes of how the solution has been diluted. I'll come back to these beakers in a moment because that's a different job altogether. And if you haven't spotted it by now, we're making a sort of a by eye colorimeter because that's where our story will evolve eventually. But there's not a great lot of differences between the solutions here. So what we can do is crank up the effort a little bit and introduce a ceroid dilution, which is a factor of 10. So 1 molar, 0.1 molar, 0.001. I'm running short of zeros, and as many zeros as you want to put in. But you can see that the solutions start to take on a far fainter appearance, obviously because you're diluting by a factor of 10 every time, not just a small amount. If it suits you, and again, if it depends on the circumstances of you and your students, but to make the solutions up in beakers has its merits. If you have enough beakers knocking around. Not sure I'd want to use glass ones all the time, but anyway, there we go. And we can make up our solutions as you've instructed your students to do so, and then introduce ingredient X, and then just by a bit of colour matching, we could try and associate X with being one or other of those solutions. And you can make that as complicated or as easy as you want to. So I suppose sometimes it might be an idea that, I don't know, it would match exactly with that particular solution, or it might be in between there and in between there. And you could ask the students to then investigate with a further set of dilutions how they could try and pin down the concentration of the unknown X. So we'll just stop at that point and look then about how do you actually make those solutions up, because it might sound obvious, but sometimes some of the finer details could just lead you astray a little bit.